Hello, in this video I am going to go through the 2023 Higher Applications Mathematics exam. So our first question is an estimation question, so we need to start by making some assumptions. So we need to get the years of schooling. And so we'll say 7 years of primary school and 5 years of secondary school. Now for these questions there is no one right answer. If you had said 6 years of secondary school or 4 years of secondary school, that would have also been fine. We also need the hours per day of school. Again, just keep it simple, whole number of hours. Don't need to get into half hours. So 6 hours per day. But other hours would have been okay, 5 hours, 7 hours. Finally, we multiply these together. So we have 190 days. Each day has 6 hours. Now that would give you the hours in 1 year. Then we need to multiply by the number of years. Doesn't matter what order you multiply those in. And you'll get right the answer. Arguably this should be rounded to maybe 14,000 because it is only an estimate, but you do not need to round it, so I'm not going to. In the next question we are going to complete a PERT chart. So we have a list of tasks and each task depends on other tasks. And that's the PERT chart we're going to fill in. So you can start at the beginning or start at the end. So let's start at the beginning. These two tasks here. These are tasks A and B because you can see they have no preceding tasks. So we know that either this task will be task A and this task will be task B, or it could be the other way around. Now let's look at this task here. The two tasks depend upon it. So let's look at what tasks depend on A. We can see that the tasks that depend on A are only task G. So that is probably not going to be task A in that box. However, if we look at task B, we can see task B has, depending upon it, task C and D. So we'll try putting task B here and task A at the top. This is B and this is A. Depending upon task B are C and D. So we'll make this C and this D. Let me get rid of that circle. Now tasks that follow on from task C and D are task E. Just task E. So E will go here. Following on from E is F. Now, this task here follows on from A and F. So A and F is task G. So task G would go here. And this task here follows on from F. So that would be H. Now I think this is a slight flaw in this question. It looks like H depends on A. But you just have to assume it doesn't. I think that could be confusing. Depending upon task G is task I, and depending upon I is J. So this is I, and this is J. Now they don't try to make things confusing for you. They have it in a fairly logical order, A, B, C, D, E. It's not like they put task A at the end. They're not trying to trip you up. Now we'll go and put the durations in. A, B, C, 8, 10, 5. And that goes in the middle box. It's not I forgot what I was saying. D, E, F, 4, 2, 4. 4, 2, 4. G, H, I, J, 35, 12. I and J, 3 and 5. Now we do the forward scan. So we always start at 0 hours, or 0 minutes at the beginning. Then we work forwards. 0 plus 8. Now task G depends on A and F, so we can't do that one just now. We have to do C and D first. 0 plus 10 is 10. The task G and H cannot start until 10 minutes. 10 plus 5 is 15. 10 plus 4 is 14. We take the later one, 15 minutes. Task E cannot start until 15 minutes. 15 plus 2 is 17. Now here, 17 plus 4 is 21. 0 plus 8 is 8. Take the later of those, that's 21. This is still only 20. This is still 21. 17 plus 4, 21. Working forwards, 21 plus 35 is 56. 56 plus 3 is 59. Now we need to be careful about these last two boxes because they must have the same number in both. 59 plus 5 is 64 and 21 plus 12 is 33. We take the later number, so 64. The entire activity cannot finish until 64 minutes. This also has to be 64. Now we can work backwards. Here it's quite straightforward because it's the same number. But here we need to work backwards. So 56 minus 35 is 21. And now we do 64 minus 12 is 52. We take, in this case, working backwards scan, you take the smaller of the two numbers. So this will have to be 21 here. Task A has, depending upon it, task G only. So this would have to be also 21. 21 minus 4 is 17. 17 minus 2 is 15. 15 minus 5 is 10. 15 minus 4 is 11. You take the smaller of the two numbers, and that's 10. Now, a way of confirming you've done this right is you look at the critical path. So you'll see on one particular path through the project, the numbers add up exactly. 0 plus 10 is 10, 10 plus 5 is 15, 15 plus 2 is 17, 17 plus 4 is 21, etc. So in other words, those tasks have no float time. So part B, when the contestant puts the bowls in the oven, that refers to task G, put bowls in oven and cook. And they realise that the oven has not been heated. That refers to task A. Task A takes 8 minutes. So when they get to this point, task G, after 21 minutes, they still have task A to do, which will take an 8 further minutes. So we have to look at when it would finish. It would finish at 64 minutes, but the whole thing will be delayed by 8 minutes. So we take 64 plus 8, type this, equals 72, and looking at the requirements of the project, 80 minutes to make it. So 72 is less than 82, so yes, they can, as 72 is less than 80. And that's it. Next question, we're going to look at some statistics. So it's asking you for the type of data. So you have 3 possible answers: discrete numerical, continuous numerical, or categorical. Now age would be recorded as discrete numerical because they would be whole numbers: 6, 7, 8, 9, 10, 11, 12. Gender is categorical, and it tells you in the question the categories: male, female, non-binary, etc. Question B is about bias or representative samples. So one reason for bias is because it is only one part of the country. So we can type that in, write that in. Only one part of the country surveyed. Another reason for bias may be because it is a survey done by email, so not everyone may have access to email. That's another reason. Not everyone has email and might not apply to the survey. You could also have said something about people might not want to admit or be truthful about who they are voting for. Although I think these two are better than that because we're talking about samples of the population. In this next question, we are working out net income. So we are given the gross income of 36,700. We use the information from the Scottish tax bands in the data booklet to work it out. So the important thing to remember is national insurance is worked out on the gross salary. However, income tax is worked out on the gross salary minus pension contributions. So first of all, we need to work out the pension contributions and take them away from the gross salary, 36,700. We'll do this on a calculator, 0.047 multiplied by 36,700. And you get 1,724.90. So now we can get the taxable income, which is 36,700, take away the pension contributions. So 34,975.10. Now this taxable income splits up into different bands of income, and each income band is taxed at a different rate. Now the ones we are going to use are these four bands here. The personal allowance has no tax paid on it, and that's £12,570. At the next band of income, it will be the starter rate, and that will be 14,732. Take away 12,570. So at the 19% tax rate, they have £2,162 of income. So I'm just going to write the tax rate here, 19%. We'll go and work it out afterwards. Basic rate tax, 25,688. Take away 14,732. And that is £10,956. That's at 20%. The intermediate rate of tax, 25,000. However, intermediate rate of tax starts £25,688, but they only earn taxable income of £34,975.10. So that's the number you use to work out the income in the intermediate rate bracket. You do not use the upper limit, the 43,662. 25,688, and let's move this up. I got 9,280. 87.10, and this will be at 21%. So now we can go and fill in what these different amounts of tax are. So 19% of 2,162, £410.78. 20%. It's 2,191. And 21% is 1,956. £950.29p, passing down to the nearest penny. Finally, we'll get the total tax, adding these together. 410.78 plus 2191.20 plus 1950.29, and we get £4,552.27 of tax. So we nearly finished this. What we would do next is take the taxable income, which we are given as here £34,975. £10. Take away the income tax for 552.27. We also need to take away the national insurance, 3,071.45. We don't need to take away pension contributions because we already did that when we worked out the taxable income. So at the end we should have had a net salary of £27,351.38p. This is an RStudio question. Question 5 uses RStudio to do a correlation, regression and regression. Question A is asking us to make a scatter plot. So you will need to load up your data into RStudio, and when you open RStudio, set the working directory. Now notice here there's no files visible, but you can see that in the Files tab. Then these formulae are given to you on your formula sheet, the data booklet. Read.csv and then attach my data. You can click on my data to see you've loaded the data in properly. Speed this up. Scatter graph would look like this. So carbohydrate content first, number of calories second, because we want calories up the vertical axis. Don't forget your labels. And your main title should mention both variables, should mention the calories and the carbohydrate content. Now when you're copying it over, if copy plot doesn't work, then you can use a screen clip or a screenshot to get it into your answer document. Now we're on to the B, find the correlation coefficient. So the command on the formula sheet to use is core.test. However, you can just use core, would work as well. Get the number here 0.92, so 0.962, put that in your answer document, and the interpretation of that is that it is a strong correlation, a strong positive correlation in fact, because it's close to 1. If it was close to -1, it would be a strong negative correlation. Now for question C, we need to do the regression line. So we use LM, which stands for linear model. In this case, the number of calories has to come first. That is our dependent variable. Copy and paste into your answer document, and you must interpret this as an equation. So number of calories equals number plus number times carbohydrate content. The interpretation of this is that 73.65 is the number if you had no carbohydrates at all. If you the 4.65 is for every extra gram of carbohydrates. That's how much the calorie content goes up by. And then for D, using that regression equation for prediction, we substitute 73.65 in. No, we don't. We substitute the carbohydrate content, the 59 grams in, and you get, it's coming, 348 calories is the prediction. So now we are going on to question 6 with the Gantt chart, and we are asked to find the critical path for the project. So the critical path will be a path from the beginning to the end with no gaps. So I start at the beginning and I look at task A, which is quite a long task. Then it's followed by task C. And then that's followed by task F. And that's followed by task G. So I think that might be my critical path. Now I'm going to read through the question carefully and confirm this. So activity G is dependent on activities F and H. So G is here, F is here, H is here. H can be delayed because G cannot start until F is finished. So H is not a critical task. F is dependent on B, C and E. C finishes at 8 days and E and B finish earlier. So again, B and E are not critical tasks. And E depends on D. But we already knew that E was not critical, so we aren't concerned about when D finishes. And finally, C and B are dependent on A. And A was a critical activity, although B wasn't. So our critical path is A, C, F and G. Just to remember, the tasks on the critical path are those with no float time. In other words, they cannot be delayed without affecting the end time of the overall project. The duration of the float time for activity B. Well, the task that depends on activity B is activity F. So you can see activity F starts here, and activity B is here, and in between there's a gap of 3 minutes. What is it, minutes? Well, hours. 3 days. Because C has to finish before F can start. That is 3 days of float time. An advantage of a Gantt chart, well, one advantage as compared with a PERT chart is you can very easily visually see the length of all the tasks. So it displays all of the it displays the durations of the times visually, or of all the tasks. In the marking scheme, it says that the Gantt chart is clear and easy to read. The disadvantage, if it asked you for that, would be that it does not show you clearly the dependencies between the tasks. So don't say that that's an advantage of a Gantt chart. That would be an advantage of a PERT chart. This next question, 7, is on accumulation. So what I like to do is to start by listing the dates that are relevant for us. So we are starting on the 1st of April 2021. Then there's another payment on the 1st of August 2021. The interest rate staying the same at that point, 1.2% a year. Then the interest rate is changing from the beginning of February. So let's put 1st of February 2022, and then there's the payment on the 1st of April 2022, and we need the balance on the 31st of July 2022. We can see from this table here that the interest rates we're going to use are these, the 1.2% a year and the 0.11% a month. So we can go and fill in these interest rate calculations, compound interest. So we start with the £400. We multiply by 1.012, that's for 1.2% increase. From month 4 to month 8 is 4 months, so that's to the power of 4/12, because we're using a annual interest rate. So that's going to give us £401.59. Then we have this payment of £200. So we add on 200 to this, and then for the next compound interest calculation, we are starting with £601.59. Now the interest rate here has not changed. We're still at 1.2%. Let's count the months. So it's 8, 9, 10, 11, 12, and 1 for January. 6 months. We don't count February because it's only till the end of January that we have the 1.2% a year. So the result of that is going to be £605.19. Then what is happening is the interest rate is changing to 0.11% a month, but there is no cash flow at the 1st of February. So we start 605.19. We have to multiply by 1.0011 to the power of something. Have to be careful here, it's monthly interest and it's a slightly more unusual number, so let's go over how you'd work this out. Add it on to 100%, you get 100.11%. Divide that number by 100 and you would get 1.0011, which is the number we've got there. And you can see from here to here is 2 months, and that is to the power of 2. Just simply 2 because we're already at monthly interest. So 0.11% for 2 months. So we get £606.52. Now we have the cash flow on the 1st of April, so we have to add on £250. So that's going to be £856 and 52p, and we are still on the 0.11% monthly interest. So 1.0011, let's count the months, 4, 5, 6, 7 to the power of 4 for 4 months. We do count July because we're working until the end of July. And again, be careful, just to the power of 4, not 4/12. So our final balance is £860 and 29p on the 31st of July 2022. Now we're going to do part B. This is working backwards from a future date. So we're in the future on the 1st of December 2022. And it tells us that the balance is £1,000. We're working back in time to the 1st of August 2022. We're just working at one interest rate here, 1.7% a year. So let's see how many months it is from the 1st of December to the 1st of August. I'm going to write the little month. August is month 8. December is month 12. Now we don't count December because we're at the beginning of December. So we'll have month 11, 10, 9 and 8. So that's 4 months that we need to work backwards. It's going to be worth less in August than in December, so we are going to divide the interest multiplier, and before I forget, that's to the power of 4, or maybe 4/12. It's 1.7 a year, so that will be 1.017. That is annual interest, so that is to the power of 4/12. That's how much was in the account after the final deposit, which then accumulated until December and at the end was worth 1,000. So before the deposit it was this amount here, after the deposit was this amount here. So we can simply find the difference between the two to find the size of the deposit on that date. That's what we get, £134.11. Okay, this is question 8, the recurrence relations question, which you do in Excel. So, video here, you are going to fill in these cells in the spreadsheet. So the first one's the units of stock, 1,750. Then the percentage stock, now it's the 20% delivery, which means 80% is left. Now be careful when you put these into a spreadsheet. Sometimes if it's formatted already as a percentage, you can type in 80. Otherwise type in 0.8. New stocks, it tells you in the question that there are 300 new units of stock each week. And you're going to put in this formula for a recurrence relation. So first of all, in week 0 is the initial amount, which you can make a reference to C7, or put 1,750. For your recurrence relation, the SQA is expecting you to use int to round at each step, and int will round down. You could use the round function with 0 decimal places, which would round to the nearest whole number. I can't justify why you have to use int. If you're looking to get full marks in the exam, remember int for recurrence relations. But otherwise, don't worry about it. So we are doing the previous number multiplied by the percentage, absolute cell reference. You can fill that down. And don't forget also absolute cell reference for the new unit as well. Press F4 on the keyboard, or if you're using a laptop, possibly function plus F4, and that will make an absolute cell reference. When you fill it down, it won't change the reference. A simple way to fill down is when you get to when you highlight the cell. Get it here. You double click the green square, fills it down, and then later on you do a graph, which is not the line graph actually, which I was trying to do there. It's the scatter plot. So not the line graph, it's that one there, scatter graph. You click on the plus sign in the top. Can I get there? That plus one for chart elements. You can put on the axis titles. Although in this particular question it wasn't required to have axis titles. Number of units at the end of the week and which week it was. Okay, so that's the Excel part of it. Remember to print the results in both formula view and in value view, which you can toggle between by pressing Control backtick, or in formulas in Excel you can click on show formulas. The graph is an exponential decay graph, which again I think is maybe potentially difficult to know. It's not a quadratic graph, it's not a linear graph. Now you could argue that it's a recurrence relation, so you could say I did actually give you the marks for recurrence relation. It is a recurrence relation you've done. There is also an exponential formula for it. But I think it is, personally, I think it's a bit silly calling it an exponential decay. So will the smaller building have enough space for the stock? Well, if we look at the recurrence relation we just did, the stable point was 1,500. So the limit was was 500. So it was 1,500, which is greater than 1,400. Oops. Why may this mathematical model be not realistic? Again, I think this is a difficult question. Just the assumptions behind the model may not be correct. So the number of deliveries may change every week. I'll type this actually. The number of units delivered each week may vary and not be exactly 20%. Okay, this next question is on inflation. So the first question is, what does this increase in CPI from 100 to 110.4 mean? Well, it means you need more money to buy the same amount of goods. That seems to me like just the kind of thing you'd memorize as a possible response in the exam. Question B you can do by proportion. So we'll make up a little table here and we'll get the price in 2021, which is 14,108. We've also got the consumer price index of 110.4. Likewise, we get the price in 2015, which we want to work out. A consumer price index of 100, and you're multiplying here by a factor of 100 over 110.4. So you do this on a calculator and you will get 12,778 pounds and 99p to the nearest penny. So part C, determine if the increase is in line with inflation. So there's multiple ways of doing this question. A simple way is to take the percentage increase in the inflation and the percentage increase in the national living wage and see if they're the same. So going from 2021 to 2022 is 119.0 over 110.4. Likewise, we'll do the same thing with the national living wage. £9.50 over £8.91. We check what both of these are and see if they're the same. So for the inflation index, we get this 1.0779. Let's give a few decimal places. I don't quite know how many I'll need. Do the same thing for the national living wage. So I get this 1.0662. Now interpreting what these means, this is a 7.8% increase and this one is 6.6% increase. So no, the national living wage has not gone up by inflation. No, it is not in line, as 6.6% is less than 7.8%. This next question is using the information in the data booklet. So part A, part 1 we can do. Looking at the information, we are told that 350,000 cars produce 750,000 tonnes of emissions in a year. And we are asked the emissions for 550,000. So you can make a little proportion table here. 350,000 cars would give you 750,000 tonnes. And then we need to find for 550,000. We multiply by a factor of 55 over 35. We get this. 1,178,571. I'll just do the nearest tons. Next question. Why might the information from the newspaper not be appropriate as part of further research? I think this might be a difficult mark to get. If you're looking to get full marks in the exam, then this is one to memorize perhaps. But one reason you could guess maybe it's newspaper could be biased. Another possible reason that is given is that the cars may change in the future to give different amounts of emissions, or if the fuel might change in the future. So here we've got this little equation here for a mathematical model, and we are asked to state the independent variable. Now the independent variable is what the other variable is the result of. So we imagine that the fuel economy of the car depends on the load. So we say that the independent variable would be the load. And that's M in our equation. And then for part 2, you are simply evaluating the formula using M equals 150. So F equals 73.6 multiplied by 0.98 to the power of M divided by 45, which is equal to 73.6 times 0.98 times, to the power of 150 over 45, which is equal to 68.8 miles per gallon. Be careful when you're putting this into a calculator. For the correct order of operations, you may need to put brackets around the exponent. So now we are on part C, where you have given 3 graphs and you have to decide which one is the possible graph that it might be. So which graph could model the depth of petrol in the tank? We can see that the cross-sectional area of the tank is less at lower depths, and as the tank fills up, it's a broader tank to fill up. So it'll fill up quicker at the beginning. So we can see in graph A, it starts by going up quite steeply, and then it slows down, and then at the end goes up more steeply again. So that'll be your answer, will be graph A. So you get 1 mark there, the correct graph, and then the explanation, because it starts filling up more quickly at the bottom, slows down, and then speeds up again and then fills more quickly at the end. The tank, I would talk about the tank as well. The tank has a larger cross section in the middle than at the top or bottom. So we are at the final question, which is a financial spreadsheet and a repayment schedule for a loan. So the loan is for £6,000 for 3 years at monthly repayments and an annual interest rate of 6.3%. So you take your spreadsheet and fill in these cells. The cell for the effective interest rate, which you can just type in 6.3% as long as it's formatted as a percentage. For the monthly interest rate, there is this more complicated formula to use because you don't simply divide the interest rate by 12. You actually raise it to the power of 1/12 and then take away 1. And if you forget that, you can just write equals C7 divide by 12 and you'll lose a mark, but you'll be able to do the rest of the question. Loan payments for 3 years. You start by guessing a repayment amount. Now you do your repayment formulae. First row is a little bit different because all those cells are greyed out, but your second row is what you fill in. For the repayment, an absolute cell reference to your repayment value. Remember, interest repayment calculations always use round to 2 decimal places and an absolute cell reference to your interest rate. The capital content is the repayment, take away the interest, and your new balance is the previous balance, take away the capital content. Once you have that second row filled in, you can highlight it and double click the green square to fill it down to the rest of the table, assuming it goes down to 36 months, which it does. Then to find the repayment amount, you will do a goal seek on the final cell, and for the loan to be completely paid off, it will have the value of 0. And you do this by changing the monthly repayment, which we just guessed before. Now, but we're not done because we cannot pay that small fraction of a penny off every month. So you have to manually round it to 2 decimal places, and you'll see the final balance there is 7 pence. So we make the final payment 7 pence greater. Now, if you'd rounded your repayment up to the nearest penny, then you would have paid off too much, and you would make your final repayment smaller. So there's 2 ways you could do it. It doesn't matter which one you do. For the total interest paid, you can use the sum function on the range for the entire column of interest, and that is what you will get there for your total interest paid. Now in part B, that's the only one actually that you write on the question sheet. You say, why might a bank reject a loan application? Well, one possible reason is that the person may have a poor credit history. So, what's his name? Ramsey may have a poor credit history. The final question is part C, and you have a new sheet to fill in, and this time it's a little bit unusual because we are using goal seek to find the interest rate. So let's see how this works. So we start by guessing any interest rate, so 5%, but it could be anything. Again, you have this weird formula to convert it to a monthly rate, raise it to the power of 1/12, then take away 1. We'll fill in these boxes later on. Your repayment formulae are just the same as before, so absolute cell reference to the repayment amount, round the interest rate multiplied by the previous balance, absolute cell reference for the interest rate, by pressing F4 or FN plus F4 on a laptop, to 2 decimal places. Capital content is the repayment, take away the interest content, and the new balance is the previous balance, take away the capital content. Once you have that row filled in, highlighted, double click the green square to fill down. Then you go to, no, I made a mistake here, didn't absolute cell reference the repayment. So I just fixed that. Go to the final balance, which should be 0 at the time at which the loan is paid off. So you do a goal seek, and this time we are going to do the goal seek on the interest rate. And we'll find out what the interest rate effectively is per year for this particular deal that's on offer with 250 repayments, £50 repayments. Now, it may be slightly surprising that we can see total interest paid will actually be a whole number, but that's because the repayments are fixed. So interest is a very round number, 3,000, but that's not a mistake. To reference a cell on the other spreadsheet, on the other sheet, you can just start typing the formula, press minus, and then click on the tab at the bottom to go to that sheet, click on the cell you want to reference, and then finish filling in the formula. And that's probably the easiest way to make a reference in between sheets. And we can see that the total interest paid will finally be 2,416. Well, the difference in interest paid between the two deals is £2,416.61.